Hello everyone, welcome to Ace Maths. In today's video, we will solve 10 exam style questions on the laws of indices suitable for IGCSE 0580 extended. These questions are arranged easier to more challenging, exactly the way they appear in the examinations. So this is the list of questions that we will be solving in today's video. I strongly recommend you pause the video and try each question before I explain it. So this is the first question that we will be solving. Here we have p cubed all raised to the power 4 divided by p raised to the power 6 all raised to the power 2. So this is a very typical case of power of a power. We know that whenever we have something like a raised to the power m all raised to the power n, we can simply multiply the indices and it will be a raised to the power m into n. So using the same logic, let's solve this question. Here we have p raised to the power 3 all raised to the power 4. So let's multiply the indices. That will be p raised to the power 3 into 4 divided by, we have p raised to the power 6 all raised to the power 2. Again, with the same logic, we will multiply the indices. That gives us p 3 times 4 is 12, p raised to the power 12 divides p raised to the power 6 into 2 is p raised to the power 12. Now here we have a division operation taking place and the bases are the same, p. So I will keep the base and I will subtract the indices. So 12 minus 12 gives 0. P raised to the power 0 is 1. Any number, any non-zero number raised to the power 0 is 1, but we need to write explicitly that p must not be equal to 0 because 0 raised to the power 0 is undefined. So 1 is our final answer. Let's solve the second question. Here we have 16a squared b squared divided by 4ab. So let's just separate all the constant terms with the variables. So we have 16 a squared and b squared in the numerator, and we have 4 into a into b. I can separate this as 16 divided by 4 multiplied by a square over a multiplied by b square over b. Now look carefully that a square over a is actually a squared divided by a, and this term here b square over b is b square divided by b. In the next step we can write 4 divides 16 4 times, so I will write 4, and then we have a squared divides a. Since here the base is a and we are performing a division operation, I will simply subtract the indices. Please note that here I have the index as 1 and here the index is also 1. Similarly, I can write b squared over b as b raised to the power 2 minus 1. This gives me 4 multiplied by a, 2 minus 1 is 1, and b, 2 minus 1 is again 1. So it will be 4ab. So 4ab is the final answer for this question. Now let's solve the third question. We have x raised to the power 8 divided by x cube all raised to the power 2. So as a rule of thumb, we will always remember to operate on the brackets first. Okay, so let's solve the bracket. We have x raised to the power 8 divided by, here I have x cube all raised to the power 2. So this is again a case of power of power. So we need to multiply the indices. That will be 3 multiplied by 2. This gives x raised to the power 8 divided by x. 3 times 2 is 6. Now again, look carefully. We have x as the base in both of the terms, and we are performing the operation of division. So I will keep the base and I will subtract the indices or the powers. So 8 minus 6 gives 2. So this is the final answer, x squared or x raised to the power 2. Let's solve the next question. Here we have x squared multiplied by 4x minus x cube. So we have a bracket here, right? So we need to know that whatever that is written outside the bracket will be multiplied by everything that is present inside the bracket. Let me write it again for you. We have x squared multiplied by 4x minus x cubed. So here this x squared will be multiplied by 4x, and this x squared will also be multiplied by x cube. So we have two different multiplications to perform. Let's talk about the first multiplication, that is x squared being multiplied by 4x. This can be written as 4 multiplied by x squared and multiplied by x. So I have actually rearranged that expression. 4 multiplied by, here we have the same base as x and we are performing multiplication. So I will keep the base and I will add the powers. 4 into x, 2 plus 3 is 3. So that gives me 4x cubed. Let's do the second multiplication. We have x squared multiplied by minus x cubed. We can put that negative sign aside for a moment. So just write it as minus x squared multiplied by x cubed. So look carefully. We have x squared and x cubed. Both the terms have x as the base and they are being multiplied. So I will keep the base x and then I will add the powers. So that gives me minus x raised to the power 5. Now, in the next step, let's combine the results of the multiplication. From the first multiplication, I have 4x cubed, 4x cubed, and from the second multiplication I have negative x raised to the power 5. So it will be negative x raised to the power 5. Since they are not like terms, I cannot simplify it any further. So this 4x cubed minus x raised to the power 5 will be our answer. Let's solve the fifth question. We have a raised to the power 4 over b squared all raised to the power 3. Look carefully, this question can be given in two different forms. Here, either you can write this division sign or you can replace it with this fraction. So be careful whenever these types of question come in front of you. Be always prepared, because most of the times students get confused. Let's solve this. We have a raised to the power 4 divided by b squared all raised to the power 3. Remember that whenever we have a power that is present outside the bracket, here we have 3 that is present outside the bracket, this 3 would be applied to everything that is present inside the brackets. So every term that is present inside the bracket would be given this power of 3. In general terms, if we have a fraction a over b and I apply a power of n to it, so the numerator a will be assigned this power and the denominator will also be assigned this same power of n. Okay, so now let's move to this actual question we have and let's apply the same logic here. With this same logic, I can write this as a raised to the power 4 all raised to the power 3, and then we have the denominator as b squared. So let's put this power to b squared all raised to the power 3. So I have distributed this power that was present outside the bracket to the numerator as well as to the denominator. Now this becomes a very simple case of power of a power. So in case of power of a power, we multiply the indices, so that gives a raised to the power 4 multiplied by 3 over b raised to the power 2 multiplied by 3. 4 multiplied by 3 gives 12 and 2 multiplied by 3 gives 6. So this a raised to the power 12 over b raised to the power 6 will be the final answer for this question. Let's solve the next question. We have x raised to the power 8 multiplied by xy squared all raised to the power 4 divided by 2x squared all raised to the power 4. So let's see how we can solve this. Here we have xy squared all raised to the power 4. There is a bracket in the numerator as well as there is a bracket in the denominator. So as a rule of thumb, we will operate on the brackets first. So we have x raised to the power 8 multiplied by xy squared all raised to the power 4. Again, we have a power that is present outside the bracket. So every term inside the bracket will have that same power. That power will be distributed to every term present inside the bracket. So this x will also have the power of 4, and this y squared will also have the power of 4. Then in the denominator, we have 2x squared all raised to the power 4. Again, with the same logic, I will distribute this power to everything that is present inside the bracket. Now, let's simplify this. We have x raised to the power 8 multiplied by x raised to the power 4, and then we have y square all raised to the power 4. This is an example of power of a power. So I will just multiply the indices. Again, in the denominator, we have 2 raised to the power 4. 2 raised to the power 4 means we are multiplying 2 4 times. That gives 16. And then we have x squared all raised to the power 4. That is another case of power. So let me just multiply the indices. In the next step, I will write x raised to the power 8 multiplied by x raised to the power 4 multiplied by y. 2 times 4 is 8 over 16 multiplied by x. 2 times 4 is 8. Now, look carefully. I can cancel out these two terms. We have x raised to the power 8 in the numerator as well as in the denominator. If I cancel out these terms, I will be left with x raised to the power 4 multiplied by y raised to the power 8 over 16. And that is the final answer for this question. Now let's solve the seventh question. Write your answer with only positive indices. So we have an expression here and we need to simplify it, and the final answer will only use the positive indices, no negative indices. Let's solve this. We have a raised to the power 4, p raised to the power minus 3 multiplied by a raised to the power minus 3 and b raised to the power minus 2. I hope you are already familiar with the concept of negative indices. So whenever we have something like a raised to the power n, we can write it as 1 over a raised to the power negative n. In the similar way, whenever we have something like a raised to the power negative n, from the concept of positive indices, we can write it as a raised to the 1 over a raised to the power n. So we apply the same principles here. It will give a raised to the power 4. Now b raised to the power negative 3 will be 1 over b raised to the power positive 3, and a raised to the power negative 3 will be 1 over a raised to the power positive 3, and b raised to the power negative 2 will be 1 over b raised to the power positive 2. Now, let me put all the a terms together. We have a raised to the power 4 divided by a raised to the power 3, and then we have 1 over b cubed multiplied by b squared. Now look carefully. We have a raised to the power 4 over a cubed. So this is a operation of division. I have the base as a, so I will keep the base a and then I will subtract the powers. And here I have 1 over b cubed multiplied by b squared. Again I have the same base b, and since we are multiplying, I will add the indices. So a 4 minus 3 gives 1, multiplied by p raised to the power 3 plus 2 is 5. So finally I have a raised to the power 1 is equal to a over b raised to the power 5. So a over b raised to the power 5 is our final answer. Let's solve the next question. This is a challenging one. Let's do this. We have a bracket, and outside that bracket we have a power of 2. So we already learned that whenever we have a power outside the bracket, that power would be given everything that is present inside the bracket. So using that logic or principle, we can write it as 3 squared m raised to the power 4 all raised to the power 2. Then we have n cube all raised to the power 2 over 2 raised to the power 2 m squared and n squared. Put the sign of division here. Then we have 3mn over this term. Now look carefully. Again we have this power of 4 present outside the bracket. So what will we do? We will give this power to every term that is present inside the bracket. So now m raised to the power minus 2 all raised to the power 4, n cube all raised to the power 4. Why? Because this power 4 was present outside the bracket. Now we can simplify it. We have 3 squared. 3 squared is 9. We have m raised to the power 4 all raised to the power 2. So that is power of a power. Let's multiply the indices. 4 multiplied by 2 is 8. Then we have n cubed all raised to the power 2. 3 multiplied by 2 is 6, power of a power, over 2 squared. 2 squared is 4. Then we have m squared and n squared. This sign of division. Then we have 3mn over 2 raised to the power 4. 2 raised to the power 4 is 16. Then we have m raised to the power minus 2 all raised to the power 4. Power of a power. Let's multiply the indices. This will be negative 8. And again we have power of power. 3 multiplied by 4 is 12. Alright. Now we can solve this further. We have 9 over 4. Right. And now look carefully. Here we have m raised to the power 8. Right. We have m raised to the power 8. And here we have m squared. We are dividing. Right. Keep the base same. That is m. And subtract the powers. So 8 minus 2. Alright. Again we have n raised to the power 6 divided by n squared. Keep the base same and subtract the powers. Alright. Put this sign of division here. And then again we have 3 over 16. And there are variables. We have m here, m raised to the power 1. And here we have m raised to the power negative 8. So we are dividing and the base is same, m. So let's keep the base and subtract the powers. Look carefully. Here we have 1 and we need to subtract the second power. The second power is negative 8. Be very careful with the signs, because you can see I have put two negative signs here. The first negative sign comes from the concept of subtraction. We need to subtract the indices. And the second negative sign is the default sign of this power that is present in the m of denominator. So we have subtracted these powers 1 and minus 8. Okay. Now we have n. So here the power of n is 1, and in the denominator the power of n is 12. So let's subtract the powers. We have 1 minus 12. In the next step we can write 9 m 8 minus 6 is 8 minus 2 is 6, and 6 minus 2 is 4, divided by 4, this sign of division, and we have 3 m. 1 minus minus 8 is actually 1 plus 8, that is 9. Then we have n. 1 minus 12 is negative 11 over 16. I'm writing on the next page now. Now we are dividing two fractions here. Okay, so I hope you remember that whenever we have two fractions, the first one is a over b and the second one is c over d, and we are dividing, we can change this sign of division to multiplication if we take the reciprocal of the second fraction. Okay, look carefully that here the numerator becomes the denominator and the denominator becomes the numerator. So I took the reciprocal of this second fraction, and this sign will be changed to multiplication. So if we use that principle here, we will have 9 m raised to the power 6 n raised to the power 4 over 4 multiplied by 16 over 3 m raised to the power 9 and n raised to the power negative 11. I have changed this sign of division to multiplication by taking the reciprocal of the second fraction. Now let me put all the constant terms together, all the numbers together. So I will have 9 multiplied by 16 over 4 multiplied by 3, and then I have m raised to the power 6 n raised to the power 4 over m raised to the power 9 and n raised to the power negative 11. Look carefully, I can cancel out 16 4 times and 9 by 3 times. So that gives me 12. And now with the variables, I have m raised to the power 6 divided by m raised to the power 9. So that is m raised to the power 6 minus 9. And then with n, I have n raised to the power 4 divided by n raised to the power negative 11. So be very careful with this. We have 4 and we need to subtract minus 11 from 4. This negative sign is because we are subtracting the indices, and this negative sign is the default sign of this index. So now we have 12 into m. 6 minus 9 is negative 3, and n. 4 minus 11 is 4 plus 11. 4 plus 11 gives 15. Now that is 12 multiplied by m raised to the power negative 3 can be written as 1 over m raised to the power positive 3, and this is n raised to the power 15. So this is 12 n raised to the power 15 over m cubed. So this is the final answer for this question. Let's solve the next question. Here we have an equation 2 raised to the power x plus 1 equals to 9, and we need to find the value of x. To find the value of the variable, we need to separate the variable from the equation. For that, let's subtract 1 from the both sides of this equation. So I will write 2 raised to the power x plus 1. I am subtracting 1 from the left hand side, and here I have 9, so I will also have to subtract 1 from the right hand side. This leaves me with 2 raised to the power x, because plus 1 minus 1 gives 0, and in the right hand side I have 9 minus 1, 8. Now look carefully, in the left hand side I have 2 raised to the power x, and at the right hand side I have 8. Try to think of 8 as powers of 2. So we have already known that 2 raised to the power 1 is 2, 2 raised to the power 2 is 4, 2 raised to the power 3 is 8. So this 8 here can be written as 2 raised to the power 3 from here. So in the equation we have 2 raised to the power x is equal to 8, that is 2 raised to the power 3. So if you compare both sides of this equation, you can see clearly that x is actually 3. So this is the answer for this question. Here we have another quite similar question. We need to find the value of x, and the equation is 10 raised to the power 1 minus x is equal to 1 over 100. So we will try to have similar basis across the whole equation. That's what we did in the previous example. Okay, so we have 100, right? 100. So think of 100 as powers of 10. Why? Because in the left hand side the base is 10. So clearly 100 can be written as 10 times 10, and that is nothing but 10 raised to the power 2. So let's go back to the equation. We have 10 raised to the power 1 minus x at the left hand side, and on the right hand side I have 1 over 100, and 100 is nothing but 10 raised to the power 2. In the next step we have 1 over 10 raised to the power 2, and from the concept of negative indices it can be simply written as 10 raised to the power negative 2. From the laws of negative indices, we already know that a raised to the power negative n is 1 over a raised to the power n. So now, if we compare both sides of this equation, we can simply see that this 1 minus x is nothing but negative 2. Solving this equation gives x equals to 3. And this would be the answer for this question. If you can follow these questions, you are well prepared for indices in the IGCSE extended exam. Pause the video and try solving them again on your own. If you'd like more such questions, let me know in the comments. I hope you learned something from this video. Thank you for watching.